1, and then the protons have got a relative mass of 1, while electrons have got a relative mass of 1 over 2,000. Okay?
Yes, sir.
Yeah. So from there, we looked at electronic configurations. We looked at electronic configurations. Electronic configuration. Yeah, what did we say electronic configuration is?
Come again, sir.
What is electronic configuration?
The arrangement of particles around the shells of an atom.
The arrangement of electrons, right?
Yes.
Yeah, the arrangement of electrons around the shells of an atom. Okay, for instance, phosphorus, whose atomic number is 15, the first shell will have how many electrons?
2.
First shell will have 2. Second shell?
8.
8. Then the third shell?
It will have 5.
The third shell will have 5, right?
Yes.
So 2, 4, 5. Very good. So phosphorus will have 2, followed by 8, followed by 5. Okay, so you at least you still remember what we looked at. Today we'll look at bonding. We'll look at what?
Bonding.
Yes, we'll look at bonding. What is bonding? So bonding is the joining together of atoms, right?
Yes.
Yeah, or we can say bonding. Bonding is the strong force. The strong force of attraction that holds the atoms together. Bonding is a strong force of attraction that holds the atoms what? Together. That's what bonding is, okay? Yes. Then there are 3 types of bonding. How many types of bonding?
3.
Yeah, 3 types of bonding. Number 1, there's what we call ionic bonding. Ionic bonding. The other name for ionic bonding is electrovalent. Electro what?
Electrovalent.
Electrovalent bonding, yes. Then number 2, there's what we call covalent. Covalent bonding. Okay. And then number 3, there's what we call metallic bonding. Are we together?
Yes.
Allow me to quickly define them. So ionic bonding involves the transfer of electrons from metals to non-metals. Okay.
Yes.
Yeah, so this one involves the transfer of electrons from metals to what? From metals to what?
To non-metals.
Yes. Then the covalent bonding involves sharing of electrons among non-metals. Among what?
Non-metals.
Non-metals only, right?
Yes.
And then metallic, of course, it is among what? Dora?
Among metals.
Very good, among metals only. So the first one is metals and non-metals.
Yes.
Then the second one is non-metals only. And then the third one is metals only, okay?
Yes.
You must know the three types of bonding, okay?
Yes.
Let us look at each one of them. We'll start with ionic bonding. So in our today's study, we'll look at ionic bonding. Then we'll call it a day.
Okay.
So ionic bonding. So we said ionic bonding involves the transfer of electrons from metals
To non-metals.
to non-metals, yes. Example, example one, we'll look at sodium chloride. Sodium chloride. Sodium, it's 11. Chlorine, atomic number is 17, okay?
Yes.
So let's draw the electronic configuration of sodium. So the first shell of what?
We have 2.
Then followed by what?
8.
Then the last shell of what?
7.
No. So we are talking of sodium.
Or 11. Okay. The last
No.
shell was 1.
1, yes. Then chlorine, let's go to chlorine. So chlorine, it will be
2.
first shell 2. So for sodium, we use crosses. Chlorine, you use dots, okay?
Okay.
Yeah, then the next shell of what?
8.
The last shell?
The last shell was 7.
We have 7, okay? But for a shell to be stable, it requires how many electrons? It requires 8, eh?
Yes, sir.
Yeah, for a shell to be stable, it requires 8. So since chlorine has got 7 outside, sodium will donate so that chlorine can now have what? 8.
8.
So after donating, sodium will become like this. We'll say we'll now have 2 inside, followed by what? Hello,
8.
followed by what?
8.
8.
Yes.
Yes, sir.
That's so, okay, because it has donated. And since it has donated, you give it a positive what?
Sign.
Sign.
You give it a positive sign or a positive charge, okay?
Yes.
Then chlorine will be like this. So chlorine,
Hmm?
chlorine,
Finish the screenshot.
So chlorine, you give it a what? Hello, are we together?
Yes, sir. Negative sign.
A negative sign, okay?
Yes, sir.
Or putting it different, sodium is positive, then chlorine is what? Negative.
Negative.
So this is what we call ionic bonding. It involves the transfer of electrons from metals to non-metals. Let's go to example 2. Let's go to example 2. Example 2, magnesium oxide. Magnesium oxide. Okay, so magnesium is 12. Oxygen is what? Is 8. So the first shell for magnesium will have 2, right?
Yes, sir.
Followed by followed by
6.
no, magnesium is 12, friends.
Oh,
So if we have drawn 2, we have a lot. We still have 10, right? Yes. Are you getting what I'm saying?
yes, sir.
Yes, sir.
Followed by 8.
Followed by 8, yes. So followed by 8. Then the last one?
2.
2.
Good. Then oxygen, it will be 2, followed by what?
Followed by 6.
Very good, followed by 6. So for oxygen to be stable, since it has got 6 outside, it remains with how many electrons to be stable?
2.
2.
So what will happen?
We'll get from magnesium.
Get from
Very
magnesium.
good. So magnesium will donate so that the friend is stable, okay?
Yes.
So in this case, how will magnesium remain? Magnesium will have how many inside?
10.
So remain with first of all 2, then 4,
8.
8. Yes. Then what do we do?
It's going to have a positive sign.
But like this.
Okay.
Why?
Because of the 2 that we removed from
That's the point. It's because it has donated 2 electrons. Okay?
Yes. Yes.
Then the oxygen will be like this. Will be like this. Because it gained what? It gained 2 electrons.
2 electrons.
Are we together?
Yes, sir.
Good. So that's how we do ionic bonding. Let me give you the characteristics of ionic bonding, then I'll give you the assignment, okay?
Yes, sir.
Okay, so characteristics of ionic compounds. Number one, it consists, or they consist of positive and negatively charged ions. That's number one. Number two, they have high melting and boiling point. Okay. Then number three, they are insoluble in water, but soluble in organic solvent such as ethanol. Number four, they conduct electricity. Hello, guys.
Yes, sir. Yeah.
So these are the four characteristics of ionic compounds. They consist of positive and negatively charged ions. And then they have high melting and high boiling point. At times, final exam, they'll ask you why, okay? Why is it that ionic compounds have high melting and high boiling point? You say it is due to the strong electrostatic forces of attraction that holds the atoms together. Okay. So why
Yes.
is it that ionic compounds have high melting and high boiling point? You say it is due to the strong electrostatic forces of attraction that holds the atoms together. Okay, then number three, they are insoluble in water, but soluble in organic solvents such as ethanol. And then finally, ionic compounds, they conduct electricity in molten state. They conduct electricity in molten state. Okay, so let me give you an assignment.
Assignment. Yeah.
Okay, so assignment. Define bonding. B, state any two types of bonding. See, show the bonding in the following. Number one, lithium, fluoride. Lithium is number 3, fluorine is number 9. Number 2, calcium sulfide. Calcium is 20, sulfur is 16. Okay, then D state two properties of electrovalent compounds. Okay, so that's your assignment. And that's it for today.
Yes, sir. Thank you.
All right.
You're welcome.
Thank you, guys. Make sure that you do the work you send to him, or you've not given them your phone number, sir. Okay, we'll end here. He's going to send the number. Fine.
Hello?
Hello, can you hear me?
Yes.
sir.
Oh, I'm saying we are going to send the phone number where you can send the answers to. On what?
Okay. All right,
Okay.
sir.
Thank you. Bye-bye.
Okay, thank you.